Hello everyone. So today we are going to solve a new problem which is going to be part of our binary search playlist. Okay, so let's discuss the name of the problem first. So our problem name is find the ceil of a given number from a sorted array. Since I already told you that it's going to be solved by using binary search, then our array must be sorted. Okay, so let's discuss the input of this problem. So here we will be given first of all a array which will of course be in the sorted form. So let me take any input. Suppose we have an array 1 2 5 8 9 then 10 and then 22. Okay, we can clearly see that it is sorted, and then we will given a value, an integer value, which we can call as target, and suppose we have 7. Okay, 7. Then the output of this should be 8. Why it should be 8? Let us discuss that. Okay, so first of all let me tell you what does ceil means. Ceil of any number means, okay, basically ceil means the nearest integer greater than or equal to x. Okay, if you have to find ceil of x, then it means that the nearest integer just greater than or equal to x. Okay, so what we have to perform in this array is basically that we have to look for this target value. Okay, what we do in like journal binary search algorithm, we will be given a target value, we will be given an array, the array will be in the sorted form, and then we have to search for this target. Okay, that is what we were doing in the binary search. So what we are going to do here, we are going to follow the main binary search algorithm, and we will look for this target value, but there will be three conditions. Okay, let me define those category or the conditions. There can be three conditions possible: first, second and third. Our target, first condition is our target is present in array. Okay, that means whatever the target value which we are given in the problem, it is already present in the array. The second category is that the target value which is given to us is not present. Okay, it is not present in array. And the third category is that if our target is suppose less than the minimum element, and we I can see that here fourth category is also possible. Our target is greater than the maximum element. Okay, these four conditions are possible here. So what will be the output in these four cases? Let us discuss that. What if the target is present in an array? Then the output should be the target itself. Why? Because the suppose we are having input as the same array, and the target value which we are looking for is 5. So what does ceil of 5 means? The nearest integer greater than or equal to 5 that is present in the array. Okay, we can see that the 5 the target value is already present in the array. So we can clearly say that 5 is the closest integer to x, I mean the target. Okay, so the output will be the target itself. What if the target is not present in the array? Okay, if the target is not present in the array, then we have to return this value, the nearest integer greater than or equal to x. Like we discussed, if our target is 7 and this is the array which which we have been given, then we have to return 8. Why? Because 7 lies somewhere in between 5 and 8. Okay, and the first greatest integer which than 7 that is present in the array is 8. Then we have to return 8. Okay, so uh, this is over. Then we can see that if what if our target is less than the minimum element. Okay, let's take this. Suppose we have target value as -1. Okay, we have, this is what we have been given. So we can clearly see that -1 will lie somewhere before 1. Okay, then we can say that the just greatest integer which is greater than the target element, that is -1, is the first element of the array. Then we have to return, in this case we have to return the ARR of 0, means the array first index value, not first index, 0th index value. Okay, and this is the last case. What if our target is greater than the maximum element? Okay, suppose we have target value as 23, and we can clearly see that the maximum element of this array is 22. So 23 will lie somewhere outside of this array in the rightmost side. Okay, we can, so in this case we have to return -1. It means there is no possible element in the array which is greater than 23 or just greater than 23. Okay, so this is what this question expect us to return the output. And the technique, the like method which we are going to use to solve this problem is binary search algorithm. So let me give you a quick review of the binary search algorithm. So if you are new to this algorithm, binary search, and you have not studied and you are like directly jumping into this problem, so I will suggest you to learn binary search algorithm. I will put the link of the binary search video in the description. You can click on that and learn, and then you can return to this video and then learn this problem. Okay, so let's discuss the binary search first. So in binary search we were given, first of all we will be given a target value. We were having 3 pointers: start, mid and end. The initial value of the start will be 0 and the initial value of end will be the n-1, where n is the length of the array. Okay, it means the last index of the array. We will assign it to end. We were calculating, first of all we will run a loop while start is less than or equal to end, and then we were calculating the mid. And what equation were we using? We were using start plus end minus start divided by 2. This was the equation we were using. Then there were 3 possibilities. What if the middle element or the array, the element at the mid index is same as the target? Then what we have to do? Else if what the middle element is greater than target? And the third condition is that what if the middle element is less than the target? So we can clearly write else condition, because there is 3 possibilities of comparison between 2 numbers, where it will be equal, it will be greater, or it will be less. Okay, so what we were doing, if our middle element was equal, same as the target, then we were returning true. Okay, what if the middle element was greater than target? It means the target was somewhere to the first half of the array. Okay, then what we were doing, we were restricting the search to the first half of the array. We were changing the end value to mid -1. And what if the target was greater than the mid element? Then we were restricting the search to the second half. Okay, so that is what we were doing. and after the loop ends we were returning false, because if this condition never met, like if this condition was never true in any of the cases in any of the range, then it means that our target value is not found in this array, then we will return false. Okay, so this was the binary search algorithm. So how we can use this binary search algorithm to solve this problem? Find the ceil of a given number from a sorted array. Okay, so suppose I will be like doing a dry run first. So what was our array? It was 1, 2, 5, 8, 9. I'm sorry for the problem. 9, 10 and 22. Okay, this was our array, and let's put the index first. 0, 1, 2, 3, 4, 5 and 6, and the number or the target value was 7. Okay, so we were looking for this. So our start will be assigned 0, we will calculate mid, and our end value will be 6. And here we are going to take another variable in which we are going to store our answer, and in this variable answer we are going to assign it with -1 initially. Okay, so first of all we will run a loop same as the binary search, and inside this we will calculate the middle index. Okay, so what will be the middle index? If our start value and end value are 0 and 6, it will be 0 plus 6 divided by 2 means 3. I am doing it in the direct way, but the statement equation which you have to use for calculating mid will be this. Okay, I have already told you why we were using this equation instead of simply adding start plus end and dividing it by 2. Okay, I have already mentioned it 2 times in our video of binary search algorithm, and in another video of first occurrence of any number in a sorted array. Okay, you can see those videos for knowing why we were using those equation if you have any doubt. Otherwise it's okay. So we got the middle index as 3, so our mid index will point to this 8. Okay, and we will match if our target is same as 8. No, it's not. No, it's not. Okay, so which three among these three condition, which will hold true? Our target is 7 and the middle index is the value at the middle is 8. Okay, so this condition will hold true. Our target is less than ARR of mid. Then we will like modify the end pointer as mid -1, means we are restricting the search to the first half of the array. Okay, so basically what we will do, whenever the middle element will be greater than target, we will be storing the middle value in the answer, and then we will like modify the end as mid -1. Okay, so we will store here 3 and we will modify end as mid -1. So what was the mid? Mid was 3 and the new end value will be 2, means our search is now restricted in this half. Okay, then again we will calculate 0 plus mid value 0 plus 2 divided by 2, and the output will be 1, and this our mid will point to this instead of 8. Okay, then again we will compare the array of mid is greater than or equal to or less than the target value. We can clearly see the mid value is now smaller than the target value. What we will do then we will restrict our search in the second half of the new range. So our start will be mid +1, that will be 2. Okay, so this is our start, this is our end. Now we'll again calculate the mid value. Okay, so 2 plus 2 4, 4 divided by 2 is 2. So our mid will point to this. So we will match if our target is less than or greater than or equal to the mid value, we can clearly see that it's still less than the target value. So what we will do, we will simply increase the start by mid plus 1. Okay, so our value will be 3. Now we can clearly see that our start is greater than end, so this condition will be false, and we will move out from this loop, and we will return this answer. And this is the index we are storing. If in the problem it is asked we have to return a value, then you have to return array of answer instead of answer. Or if the index is asked, then you have to return simply the answer value. And we can clearly see we have 8 in this in the third index, and this is what we were expecting. So let me write the code for this somewhere here, and we will discuss the time complexity. It is, by the way, easy to find out the time complexity in this type of solution, but anyways I will tell. Okay, so what we have to take first, we will be given a target. I'm not writing full code, I'm just writing the main algorithm. Target, we will be given target. We will declare we will be given start, end, and mid. Mid will not be given, we have to calculate it. Okay, I'm just declaring, means if this is the these are the variables which we have to declare. Okay, then we will declare a variable answer, in which we will initialize it with -1 initially, and we will run a loop while start is less than or equal to end. Then we will calculate mid. Mid is equal to start plus end minus start divided by 2. Then we will match the mid value with the target value. Okay, if our array of mid, or we can say the element stored at the mid index, is same as the target value, and you can clearly see here this was the condition, if target is present in the array, we have to return the target. Okay, it means we have to return target. Okay, or else if our middle element is greater than target, it means we have to restrict our search in the first half of the array. Okay, so first of all, before doing that, before changing the end value, we will store the mid value in answer, and then we will modify end as mid -1. Okay, because we have already got one greater value, but we are looking for something smaller than this larger value, but greater than or equal to this target value. Okay, this is what it means. And the third condition, where we can clearly say it is not equal, it is not greater, then our middle element is less than the target value. Here we will just restrict our search to the second half of the array, and we will do start is equal to mid plus 1. Okay, this is what we were supposed to do. What if we don't have any target? Means we don't have any similar value or the same value target present in the array. It means that this condition will never hold true, and we will get something. Okay, we will get something, either we will get -1, either we will get some index, we will get something. Okay, so we will check here first. If our answer is equal to -1, then we will return answer. Okay, otherwise we will be returning ARR of answer. Why I did that? Because suppose there we are getting our target value is greater than the maximum element of the array. It means we will be getting -1 in the answer, because it will never be modified. Okay, so we can't return array of -1. Why? Because array indexing starts from 0 and goes till n-1. Okay, that's why we are returning, if our answer is equal to -1, then we will return simply -1. It means that there is no element possible in the array which is just greater than or equal to our target variable, and if it is not equal to -1, then we will return array of -1. Okay, this is the actual code of this problem. Let's discuss the time complexity and space complexity. So the time complexity will be same for this question. This will be same for like what was the time complexity of the binary search. Why? Because the same algorithm we are using, we were just modifying the binary search algorithm to get this problem solved. Okay, so our time complexity will be log n, and since we have not used any extra space, so our space complexity will be order of 1, we go of 1. So this was the problem. I hope you can easily read the code, and if you are finding any difficulty in like reading stuff, like if you are, something is not visible, so I'm really sorry. I hope you understood this problem, and do solve this problem. It's very famous, and I will categorize this problem in easy category. We will first be starting with the easy problems, and then we will move forward with the medium level and the hard level problems. Okay, so if you like this video, you learn from it, then do drop a like. If you have any issue with this video and my learning techniques, then you can surely suggest me something which you like in the comment section. And that's all. Thank you and have a nice day. Bye.